Hello dear students, we already talked about Gibbs free energy and we said that this is the energy capable of doing work. Now we will show that why do we need to know about this terminology in biological systems. So the living cells require some sources to provide energy, and the fact is that the cells are isothermal systems, meaning they function essentially at constant temperature. इसका क्या मतलब है कि किसी भी लिविंग सिस्टम में फॉर एग्जांपल अगर हम ह्यूमन बीइंग्स की मिसाल लें तो हमारी बॉडी का टेम्परेचर 37 डिग्री सेंटीग्रेड है, यानी हमारी बॉडी के तमाम तर सेल्स सिर्फ 37 डिग्री सेंटीग्रेड पे ही सही काम करेंगे. अगर टेम्परेचर 37 डिग्री सेंटीग्रेड से रिड्यूस हो जाए तो वी कॉल द सिचुएशन एज हाइपोथर्मिया, whereas if it would increase from 37 degree centigrade we call the situation as fever or hyperthermia. And this is because of the reason that when the temperature of the body is changed, the cells are not in harmony anymore. This means that for the biological systems, heat energy is not the ideal source of energy because of the fact कि heat energy तभी काम कर सकती है when it passes from a zone of higher temperature to the zone of lower temperature. In that case, the energy that the cells can utilize is known as free energy or Gibbs free energy. And this depends on the concentration of the reactants and products in the reaction. Another point is that the amount of delta G allows us to predict whether the direction of the chemical reaction would be forward or reverse. Also, it lets us to find out the exact equilibrium point of the reaction and the amount of work done. The amount of free energy for a reaction is independent of the pathway by which the reaction occurs. What does this mean? This means that whether a reaction occurs in several steps or it is a direct reaction, there will be no effect on the net amount of delta G of the reaction. So point number 4 is that the free energy changes are additive. इसका क्या मतलब है? This means that when a reaction takes place in several steps, यानी अगर कोई reaction several steps में हो रहा है या there are 2 or 3 intermediate steps while carrying out a chemical reaction, then the total free energy that will be produced in the reaction will be the sum of delta G values that will be either produced or consumed during each individual reaction. And we will discuss all these points during the lesson. But before that, we should know what is standard free energy. The free energy of a reaction under the standard conditions is known as standard free energy. So what are the standard conditions? When a reaction takes place at the temperature of 298 Kelvin or 25 degrees centigrade and the concentration of the reactants and the product is 1 molar, and if you are dealing with the gases, then they are at the partial pressure of 101.3 kilopascal or 1 atmospheric pressure, then the system is under the standard conditions. And you can see that the standard free energy is denoted by G naught. Naught is this small zero like sign here, and this depicts that the reaction has taken place under the standard conditions of temperature, concentration and pressure. And the equation that we studied before that relates delta G with enthalpy and entropy of the system, it can be written in this way. You can see now it states that the changes in standard free energy, meaning delta G naught, is equal to delta G H naught minus the product of temperature and changes in entropy under the standard conditions. However, most of the biochemical reactions occur in well-buffered aqueous solutions which have got the pH 7, and both the pH and concentration of water are taken as constant. We will see in next slide that how the concentration of water is 55.5 molar, and under the conditions when the pH of water and the concentration are taken as constant, then delta G is written with a prime. This means जहाँ भी आपके पास डेल्टा जी प्राइम के साइन के साथ रिटर्न हो, this would indicate that the reaction has taken place under this much concentration of hydrogen ions and this concentration of water. And other key convention is that the concentration of water, hydrogen ions and magnesium ions are not included in the equations for the purpose of simplicity. Now coming to the fact that we said that the molar concentration of water is equal to 55.5 mole per liter. So how did we calculate that? Suppose that we have got 1 liter of water. 1 liter would be equal to 1000 milliliter. Density of water is 1 gram per milliliter. So the density of 1000 milliliter would be 1000 gram per liter. The molecular weight of water can be calculated in this way, that we add the atomic mass of 2 hydrogen atoms plus the atomic mass of 1 oxygen, which comes equal to 18. And the molar concentration of water can be calculated by this simple formula, which gives us the answer and shows that the molar concentration of pure water is 55.5 mole per liter. We must be careful to distinguish between the two different quantities, delta G, the actual free energy change, and the standard free energy change. So the actual free energy change is denoted by delta G, whereas the standard free energy change is denoted by delta G naught. And whenever delta G naught comes with a sign of prime, it means that we have taken the values of pH and concentration of water as constant. And from now onwards, delta G prime naught will be used to represent the standard free energy change of the reactions. Each chemical reaction has got a characteristic standard free energy change, and the value of standard free energy change can be either positive or negative or zero, depending upon the equilibrium constant of the reaction. So we might have understood now that the value of delta G prime naught for a reaction is constant because of the fact that the reaction has taken place under some standard conditions of temperature and pressure. Meaning, अगर आप किसी particular reaction की बात करें तो उसके लिए एक particular temperature और pressure पे delta G prime naught की value हमेशा same ही रहेगी. Whereas the actual free energy change is the function of the concentration of the reactants and the products. Meaning, the amount of actual free energy change can vary with the temperature, and it can vary with the concentration of the reactants and the products. This indicates that the value of actual free energy change of a reaction is not similar to the changes in the standard free energy of the reaction. Now coming to the fact that the criteria for the spontaneity of the reaction is the value of delta G, meaning actual free energy change, and not the change in the value of standard free energy. So this indicates that if the amount of delta G is negative, then the reaction would be spontaneous or exergonic, and it would tend to go in the forward direction or the right side of the equation. On the other hand, if the amount of delta G is positive, this indicates that the reaction is not spontaneous. It tends to go in the reverse direction or the left side of the equation. Whereas, if the value of delta G is equal to 0, this indicates that the free energy of the reactants and products is equal to each other, and at that particular moment the reaction is at equilibrium state. And by this, the present lecture comes to an end. Thank you.